Hello guys, how are you? I hope everybody be good. No, we are gonna talking about the band structure for phonetics. Okay, then you should know that we have many methods to calculate the band structure for the phonetic crystals. Number one, we can use power wave expansion. Number two, we can use transfer matrix. Number three, finite element method, and we can use the finite difference in time domain. We have mentioned before that we are talking about the these equations the final equations which are deduced or proved from the four equations for the Maxwell for the electromagnetic wave. Then we can find the final equations after some integrations and some derivative and some substitutions. It's not concerned with this proof. We need only this form for our lattice or phonetic crystal. Okay, we are in the cycle cycle. This is eigenfunction, and this term W divided by the C square for each term is called the eigenvalue. Okay, some scientist is called Bloch or Bloch. This man is find solution for this equation. So someone asked me why you are going to solve this equation, or what's the difficult points I can face to solve these equations. Okay, you will need to, or I going to solve this equation to find an easy way, because I have two problems in my phonetic crystals. The problem of number one, I'm dealing with infinite structure. Not fixed dimensions. The problem number two, I'm dealing with some materials periodic, which are periodic each period of time. I have these materials, and after that materials another material with another refractive index. Then I have another materials. You have periodic materials. So these 2 points is the problem for this man to solve and find easy relation to solve this equation. I'm using what's called plane wave, because we are dealing with the using power wave expansion. Okay, please, I need you to easy this problem. What we mean by plane wave? Okay, let me assume that you have B bars. Okay, these B bars have a dimension. In our electromagnetic wave, or in engineering, it's called plane. This is number one. If I have the 3 dimensions, lattice equals triangle, this is plane. This lattice is plane, and we have another plane, which all of these plane are consist, or the content of the structure, or this is the structure of my lattice or photonic crystals. Okay, then why I'm using ion plane wave? Why this? Because I'm consider that the electromagnetic wave which are produced from the source or light source is entered and moving in our free space as plane and plane each are equals each other. Okay, then we use these equations plane wave or how this man dealing to sample to make this equation is very simple. I'm using, if I have eigenfunction inside a periodic structure and infinite, we can represent this equation in this equations, which mean what we mean by this equation. This equation is meaning that you have the function, and this function we can find in this function multiplied by our exponential function. We can present this by this. These are concerning only with the periodic lattice or periodic function only. Okay. We also mentioned that when we are dealing, please guys, let me some. Welcome back, guys. We are mentioned before and we are explained that the permittivity function in the direction of this is equal to the permittivity for x and divide and plus r, because we have materials and we have another materials and we have a materials number one again, then one and we have two. The permittivity is this equal this, but it's adding this distance. So what we mean by this, we are mentioned. Okay, you are know or you have mentioned in the last lecture that the lattice vectors we can divide in the reciprocal, or if I am gonna ask you one question, what is the relations between the lattice reciprocals and the lattice of the lattice vector and the reciprocal. Reciprocals, which we are described it by G product by IR equals this equation. Reciprocal lattice vector G lattice vector which are mentioned by R. So we are mentioned this before and we are mentioned this before. We mean by A1 and E3 and E, this is the directions which our lattice, which is the structure of our lattice can change. If I'm saying that I have crystals which have one dimension all change in y direction, the two terms is equal 0, because we are dealing in the structure. You should know, keep in your mind that we are dealing in the crystal, the lattice crystals or the phonetic crystal, structure crystal. We are dealing with the vector which occurs the change. We have the change in this. We have another material, the first material, second material, blah blah blah. We have the direction in this direction. Okay, mean one or another one can call me the change occur in z direction. Okay, this one and this one, this other. So I have this vector which equals z. Okay, so we are dealing in the G. You should keep this equations. Okay, I need to look with these equations. We have mentioned before that these equations when I putting the block 4, we can substitute it to give these equations. These equations came from this supposition, from this assuming to gain this. Or if I put this in these equations, I can find this last equations, and we have key vector and we have state of number. The next lecture we can dealing with the unit cell, or what we mean by the unit cell in the structure of the phonetic crystals. And goodbye everyone, I hope you will, and we will continue in another lecture, and welcome, goodbye.